So please, good evening to everyone and welcome to the program. As I told you yesterday that I will take up another parametric statistics, and the name of that statistics is McNemar test. As we have been talking about the assumptions, so one of the assumption is that there must be two discontinuous variable, and this continuous variable means what? Means, for example, pass and fail. This is one. Another can be safe and unsafe. Another can be yes and no. Another can be low and high. Like this, you can have the two discontinuous. So there should be two discontinuous. When I say variables, pass and fail. These are two categories of the variable. Another is that the two groups must be mutually exclusive. What is the meaning? The meaning is either you belong to the pass group or you belong to the fail group. The same person cannot belong to both the groups. That is the meaning of mutually exclusive. So that is another important. Then another is the sample is selected through random sampling from the population. Then another is that it is used on paired nominal data. That once you have pass and fail, so say data will be nominal. That means tally. Then another is that here for each one there should be two categories. So therefore, I have already said two discontinuous variable, or you can say it is used on 2x2 contingency table. In other words, it is used in 2x2 contingency table. So these are some of the assumptions. My dear friend, how will you repeat it? If there are 10 people, out of which 8 are in pass category and 9 and remaining are in fail category, how will you repeat it? So there cannot be any choice for the repetition. And there are always two categories because it has to be 2x2. So Sunita, no, absolutely no. The meaning of mutually exclusive means that you can only belong to the one of the group or one of the level or one of the category of the two. Either you belong to this category or you belong to this category. Suppose you administer a test, and when you administer the test, let's say it is achievement in English. When you administer it on 50 people, some people will fail and some people will pass. So you know, out of 50 people, how many have failed and how many have passed. Now you teach, and as you teach, then you give the same test again. And then you have to see that how many people out of 50, they pass or they fail. So therefore, the position of pass and fail before the treatment and the position of pass and fail after the treatment. So therefore, here I can have a title is something like this. I can say a study of effect of models of teaching or concept attainment model on achievement in, say, English of class 5th students of public schools of them. Now, see here, I can have the data on interval scale, but if I do not want to have data on the interval scale, I have to put the data on the nominal scale. Then I can convert it into the pass and fail. So I may have the objective like this. Objective is to study the association, because association, I told you, is when you have the nominal scale data, association between the models of teaching and the achievement in English of students. So here, if I do not write the word association, and if I write the word mean, then it will be in the probability sample, it will be in the parametric statistics. So because I know that I have the data which is on the nominal scale, so therefore I have to use the word, association. So that means I must know that I administer a test, and that test will be achievement in English. And then I see how many students pass and how many students fail. And then I teach them through models of teaching. And then after, let's say, 1 month or 15 days or 20 days, or I administer the same tool again. And then I have to find out that after that, how many people, how many students pass and how many students fail. It is quite possible that before teaching, some students pass and some fail. After you have taught, those who have passed, all of them may not pass, some of them may fail. And those who failed earlier, then after the teaching, some of them may again fail, all of them may not pass. So therefore, I will have the data and will tell you how it is to be done. And hypothesis is there is no significant association. There is no significant association between models of teaching and achievement in physics and achievement in English. So let us have the data. You can take as much sample as you like. You may take 100, you may take 50, but you cannot take 5 or 6. So let us go to my data. Now here I define. One is before teaching. There are 2 levels. One means pass and 2 means fail. Then another is after teaching. And again, there will be 2. One means pass, 2 means fail. Now I go to my data. Now suppose here it is before teaching. So the result is like this. Suppose I have this much. Now I will teach them through concept attainment model. And after that, I again administer the same test. And then after that, I see the result. Suppose this is the data. Now I go to analyze, and then I go to my non-parametric statistics. And then because I have the two related samples, so I have already done Wilcoxon, I have already done Sine, I have now do McNemar. So I say McNemar, and let me shift them here. I shift them here. Now here my data are on the nominal scale, so I can't calculate descriptive, and I go ahead. And this is my result. That this was the situation that 20 people passed and 11 people failed. And once you have taught, then those who passed earlier, there were 8 failed. And here, those who failed, they have failed and some other people have failed. And some people might have passed also from this. So this is the situation before teaching, and this is the situation after teaching. And now here you see this particular significance, it is 64. That means it's not significant. That means there is no significant change. That means your treatment had no effect on achievement in English of the people. So there is no association between the achievement in English and the method of teaching. So this is what exactly it happens. Now, if you want to still have some more data, you can have the more data, no problem. Let's see what is the result now. Now, because there the chi-square value was very low, so therefore it did not display. Now here it has displayed. Now chi-square value is 1.33 and it is not significant. Let us try to make some more changes in the data. Now you see here. Now you'll see the chi-square value is 2 points. Still, it is not significant. Because here the error is 13%. In the earlier case, it was 24%. So if you want to do more, you can do, no problem at all. So let us see, how do I analyze this particular data? Which one should I take? Should I take chi-square is equal to value is 1.33? Or should I take chi-square value 2.250? Which one do you want? Which one do you want? Because you ask anyone you like, it does not make a difference because the interpretation will be the same. It does not matter. So let us see how do we make the table. Now here, this was my objective. And here it will be 4.17.0 or 18.0. Let us see, 4.17.0. So it is association between because here I think I wrote concept attainment model. So here also I can write concept attainment model, no problem. Concept attainment model. So association between concept attainment model and achievement in English of students. Then I'll say the '17 objective was to study the association between concept attainment model and achievement in English of students. The data were analyzed with the help of McNemar McNemar's test and the results are given in table 4.70. Let's have insert the table. So here it is before, pass, fail. Now you have after. So there should be one more column. Let us say I make the space here after pass, but I say after it is pass and then I say fail. And then I'll say here, how many people? This is 42 and this was 30. Then here it was 23. This was 20. And this is your chi-square value. Chi-square value. And chi-square value was 2.250. So you can say frequencies of pass and fail before and after frequency of pass and fail before and after teaching. Frequency of pass and fail before and after teaching. Or I should say, the chi-square value, frequencies and chi-square values. What do you think should be the heading of this particular table? Frequencies of pass and fade before and after teaching is fine, but then chi-square value should also come. Because these are the frequency and this is the chi-square value. Or you can say chi-square of frequency, ये भी हो सकता है. Chi-square value of frequencies, chi-square values of pass and fail frequency before and after. ये ठीक है, this is okay. Chi-square values of pass and fail frequency, pass and fail frequencies of subjects or of students before and after teaching. Of students before, this is okay. Chi-square value of pass and fail frequencies of students before and after teaching. That's quite all right. No, not table showing. No. So let us see how do we interpret. From table 4.17, it can be seen that chi-square value is 2.250, which is not significant. It indicates that there is no significant association. There is no significant association between that there is no significant association between between concept attainment model model in this. So there is no significant association between concept attainment model and achievement in English of students. Thus, the null hypothesis that that there is no significant association between the concept attainment model and achievement in English of students is not rejected. So it may be said that achievement English of students was found to be independent of concept attainment model. Or you can say there is no significant effect of models of teaching on achievement in English of students, or this is also all right. So this is how you have to write the interpretation of the McNemar. And this is what exactly is the, and if it is significant, then you can say it is significant and there is a significant association. Now, do you want to take another example or what? Do you want another example or is it all right? Let us see. We have that I'm having a title like this. A study of effect of physical exercises on weight of weight of people of 30 years of age of Delhi. Suppose I have this. Then I may write objective like this. To study the association between physical exercise and weight of students, weight of people. Suppose my hypothesis is that there is no significant association between physical exercise and weight of people. Now what I will do is, I'll go to my no, I told you, if your hypothesis is not rejected, you cannot use the word accepted. Why? Because in your research, your null hypothesis is not rejected, and in somebody else's research, if conduct the same type of research, then the null hypothesis may be rejected. So once you, because all books, they write accepted. See, accepted is a very strong word. And accepted word you can write only and only if you collect the data from all members of the population. And in research, we never collect the data from all members of the population. So therefore, you cannot write this. And I have also explained it to you in earlier also, and now again I have explained. So let us go to the sheet, and here I have if you want to remove, you can remove it, no problem. So it's all. Again, you can write here before the physical exercise and after the physical exercise. If you want, you can write before and after, or the choice is yours. There are two levels. One is it is a normal weight. Another is, it is, or I will say, now it is say reduced. Reduced weight or loss in weight. And after the exercise, again the two levels. One may be normal and another may be loss in weight. So now I enter the data. I'm writing the normal first. Suppose I have this much data. Now I go. After the exercise, suppose I've done this. Let's go to my, then go to non-parametric, then go to two related samples. If you want to remove them, you can remove it, no problem at all. Now here is, before this is optimized. McNemar is already active, so you say this. So here your chi-square value is 0.006 and it is not significant. Do you want a significant value? Now just see here, it is loss in weight. It's the same. Okay. If you want, you can try again. Let us see. Maybe I make some changes. Let us see what value now you get. Now it's not significant because it is still 1.446 and it is 22.9% error. So you can again make the changes and then you can try to see that what might be the values. Let us try if I can. I don't think we will. Yes, something better. Maybe let us may try to do more. Maybe we get a okay. It is. Let me still try to make some more changes. Okay. Let's say here is the one. Now the chi-square value is 7.48 and it is significant at 0.01 level. So let us see how do we write the interpretation of this. So it is 18, it is 51, it is 26, and the chi-square is 7.48 and it is significant. And DF will be 1 because it is 2 by 2. So column minus 1 and row minus 1. So it is 1. So let us see. So here This is 4.18.0. Association between physical exercises and weight of people. Eighteenth objective was to study the association between physical exercises and weight of people. My dear friend, I want to make one announcement and please listen carefully that tomorrow I have some work. So I want to take your class from 6:30 tomorrow, only tomorrow. Class will be from 6:30 p.m. to 7:45 p.m. So please note this particular change, and I will request the Gupta to further inform all the participants about this change. So this is only for tomorrow. Day after tomorrow, it will be the normal time. Okay. Now the 18th objective was to study the association between physical exercise and weight of people. The data were analyzed with the help of McNemar, with the help of McNemar's test and the .8. So table 4.80. Let me copy this table and I will make the changes. It is 18 chi-square for chi-square value of normal and reduced weight frequency of people before and after physical exercise. exercises. Now here, so this is normal. And this is reduced. This is normal. And this is reduced. Now here, the normal before is 18. And reduced it 50 months. After is 26. $55. The value is 7.48. If you want to add one more, you can say remark. And you can say P is less than 0.01. Now you say from table 4.18, it can be seen that the chi-square value is 7.48, which is significant at 0.01 level with df equal to 1. It indicates that there is a significant association between physical exercise and weight of the people. Do you want to say weight of the people, or do you want to say change in weight of the people? Weight of the people, no problem. Yes, they say there are 26 people who before the exercise, they were in the reduced one, and after the exercise, they have become normal. It can happen because when you do exercise, you may increase your food intake and you may gain the weight. It is possible. So therefore, it indicates that there is significant association between physical exercises and weight of people. Thus, the null hypothesis, there is no significant association between physical exercising and weight of the people is rejected. So now you can see that from the table earlier, the normal people, when they were before the normal, okay, and now after that they have reduced. So reduced the people, those you improved or those who have reduced their weight, that is much more. So that means physical exercise help in reducing the weight. Furthermore, more people reduce their weight after doing physical exercise. So it may be said that physical exercises help in reducing the weight of people. That's all. Or you can say it may be said that there is a significant association between the physical exercise and weight of the people. That also you can say. Or you can say that it may be said that there was a significant association between physical exercises and weight of people. So therefore, this is how, if you have there is a significant association. So thus the null hypothesis, that there is no significant association between this is rejected. Further, so therefore I have written there is significant association. So therefore, you may write this as your height, that there was a significant association. You can write this, or you can write that physical exercises help in reducing the weight of the people. So any conclusion, any finding you want, you can write. So I have taken two examples where in one example, the chi-square value was not significant. In another example, the chi-square value was significant, and therefore I have already mentioned that. Now, Prashant, if you use the mean, word mean, then it can be the paired sample t-test, provided you use the word mean. But here we are not using the word mean. Therefore, it cannot be. Number one. Number two, yes, it is 2 by 2 chi-square. But in chi-square, we directly have the frequencies. And here, of course, we have the frequencies. That is why you have used chi-square. So it is quite similar to the chi-square, but not similar to the paired sample t-test. Because paired sample t-test will compare the mean. And here we are not comparing the mean. So this is what, and paired sample t-test is a parametric statistic where normal distribution is one of the assumptions which your data must fulfill. Okay, any other question you want to ask? And if there is no other question, then I am closing it here. And please, tomorrow class will be from 6:30 to 7:45. And tomorrow I'm going to take another statistics, and that is a Friedman analysis of variance by rank. So that means your data will be on the ordinal scale. So that I will take it up tomorrow. So you can relax and see you tomorrow at 6:30. Till then, stay safe and keep learning.